name and a little about your project.
My name is Peter Higgs, and in 2013 I was awarded the Nobel Prize in Physics for theoretical discovery of what is now known as the Higgs Boson particle. In 1964, I established a theory that a particle existed in an invisible field that explained how other particles got their mass, and in 2012, the particle existence was confirmed.
What were you guys trying to do?
Myself, along with many other physicists, were looking to explain the existence of mass in subatomic particles. During the time of discovery, other physicists had already modeled subatomic particle behavior. These models confirmed experimental data patterns, and each term in the equations were symmetric as long as these particles were massless. So instead of attempting to disprove this equation, I took the path of explaining what gave the fundamental particles their mass.
Awesome to hear. All right, my next question is, where did the project or experiment occur?
In 1964, I submitted a paper in the Physical Review Letter. At this time, I was working as a lecturer at the University of Edinburgh's Tate Institute of Mathematical Physics. But this was all theoretical and could not be proven through experimentation at the time. It was not until July 2012 when scientists at CERN confirmed that experiments ATLAS and CMS on the Large Hadron Collider had discovered a boson similar to that in which I had theorized years prior. And the analysis confirmed the boson to be consistent with my predictions.
All right, Peter. So I'm sure there were a lot of other events happening around the world at that time. Please let me know, like, what else was going on at that time?
Well, during that time, the average UK citizen cared more about actor Peter Sellers getting married, and those who weren't concerned about actors were up in arms about the British military's presence in Cyprus. Americans were at the height of the civil rights movement, and with Muhammad Ali becoming the heavyweight champion in boxing, controversy towards the Nation of Islam was at an all-time high. The Vietnam War was happening. It was a time that many conflicts, but at least we had the Beatles.
I hear you there, Peter. Who else was involved in this project? Were there any other players or team players?
Yeah, the carrier particle was proposed by myself and Francois Englert, who also was awarded the Nobel Prize for the discovery. But we could not have proven this theory without the scientists at CERN in Switzerland.
A dream team. What was your role in the project?
This was an independent study based around the standard model. However, other physicists were coming to similar conclusions as I was around this time.
All right, so can you tell me, what do you think was the largest impact of your project?
As far as the impact that I think the project had on the physics community, verifying the existence of the Higgs boson particle signaled the existence of the Higgs field. The idea that an invisible field is present throughout the universe that gives fundamental particles mass opens a world of possibilities, such as doomsday caused by quantum tunneling, which in turn would cause the universe to undergo major vacuum decay, with the vacuum expanding at the speed of light. It could also lead to explaining supersymmetry, which is the existence of a particle antiparticle, as in the standard model, and a supersymmetric partner particle that would theoretically help stabilize the universe.
All right, Peter. Were there any technical problems that you felt you encountered during this project or became a concern for you?
Definitely the Goldstone theorem. Particle symmetry has always excited me. The ideal of a spontaneously broken symmetry implied that the base was symmetric, in which in a and which in turn helped me understand these asymmetric values found in a vacuum state were not exact values, something that many physicists paid no attention to at the time. But the primary issue with this theory at the time was the zero spin particles in this model were massless. And although everything pointed to this theorem being in this theorem being true, the fundamental particles were not massless.
All right, Peter, it has been a pleasure interviewing you, and thank you very much.